Welcome back to Advent of Code 2016, day 18. We are 1, 2, 3, 4, 5, 6, 7, 8 problems away. Well, sort of 16 problems if you count all the individual parts. 15, actually, because day 25 is just one part, usually. Just open one of these 0-calorie drinks. These are so good. I just assumed 0-calorie drinks wouldn't taste good, but it does actually taste really good. All right. So ChatGPT has beaten us 14 out of 17 problems. That's I mean, that's in line with what I was expecting, to be honest. All right, let's begin. Like a rogue. What's this about? Something to do with tiles. It doesn't look like a BFS problem. It's some sort of calculation. All right. Hang on, adjust the camera. All right, so as you enter this room, you hear a loud click. Some of the tiles on the floors here seem to be pressure plates for traps. Is this going to open a Wikipedia on traps? Oh, this is NetHack wiki. Okay, we're in the NetHack world now. That's cool. I mean, I've played NetHack a couple of times, but I've never got into depth. I should look into it more. Hello, DJ. It's going well. We're in the end game now. Only like 6 problems left, I think. It's day 18, so it's like, yeah, 6 or 7. So this seems to be something to do with a grid map, but I don't think we'll actually have to search or pathfind. Got a speedrun the last 6. A lot of people do that, yeah. They put up a live split and everything, and they try to speedrun through them, but I don't like doing that. I mean, I wouldn't be able to talk while doing it. I would just be like typing and stuff, so it'd be a really boring stream. Where was I? So, okay, yeah, we walk into the room and there's traps, alright. Upon closer examination, the traps and safe tiles in this room seem to follow a pattern. The tiles are arranged into rows that are all the same width. You take note of the safe tiles, dot, and traps. What's the name of that symbol? I forgot. Circumflex? No. I can't remember. In the first row. Alright, this is bugging me. I've got to search it. It's that. It is actually circumflex? Is it? No. Carrot. Carré. Carré? Is it French? Interesting. Wait, so... Okay, it is actually called circumflex as well. Oh, no, but this circumflex is the one that you put over letters. That's why I remember that, because when studying French and not German, and Spanish and stuff. Wait, do they even have that in French and Spanish? It must have come up when I was studying languages at some point. Alright, the type of tile, trapped or safe, in each row is based on the types of the tiles in the same position and to either side of that position in the previous row. If either side is off either end of the row, it counts as safe because it isn't a trap embedded in the wall. Okay, fine. Alright, so suppose you know the first row. I want to determine the next row. The type of tile 2 is based on A, B, and C. Okay. Based how? It's... So, if any of these 4 situations... Okay. So it's a trap if either it's trap, trap, safe, safe, trap, 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 safe, 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 trap. Okay, fine. So it's almost like a kind of game of life simulation sort of thing. Alright. And we count how many... How big is this? That's it? Oh no, that's one... Okay, that's one row. And it would go... 40 rows. That's totally fine. Again, I don't see any issue here. You just literally just code this as a Boolean condition for each row, one by one. Alright, let's do it then. Okay, so we need... Again, we don't actually need to use input.txt. We can just copy this straight in. I have a feeling ChatGPT will get confused. Really? I don't think so. It gets confused when it's really wordy and there's kind of tricks to it, but I think this looks pretty algorithmic. The English is easy. The conditions are in kind of pretty rudimentary English. I feel the opposite, to be honest. I guess we'll find out. It feels pretty safe for ChatGPT. It just doesn't... It doesn't... For one thing, it doesn't even need an algorithm. That's usually one thing that ChatGPT trips up on, not knowing the smart way to do something. But in this case, you literally just code as the description gave us. Right. Alright. That's the row. Okay, fine. So count equals 0. That's how many what do we need? Safe tiles. How many safe tiles we get? Okay. Alright, let's just make a method here. Given I don't know, an index. We want to produce the next row given. Hang on, no. Let's say get tile index. All right, so that's saying for this new row that we're looking at, I want to know what title. I want to know what tile is at index I. All right, so all right, say left equals, so the left tile that we want to look at is row I if I row I minus 1 if I is strictly greater than 0, else it defaults to, wait, so dot is safe, right? Dot, yeah. Okay, center equals row I, right equals, and then similar condition here. Row I plus 1 if I is strictly less than length row minus 1. Else dot. Okay, so now we've got left, center, right. If left plus center plus, all right, left plus center plus right, if it is in the following okay, so the 4 conditions that can be are trap, safe. So safe, trap. So Slinky, did you end your European tour? I guess you must have. It's been quite a long time, actually. Trap, safe. Safe, trap. All right, if it's in one of those 4, return trap. It's a trap. Yeah, it's a trap if it's either of these 4, so it's that, else turn right. So for in a total of 40 rows, so we generate 39 more rows. Okay, so we do count plus row dot count dot. So we count how many safe tiles there are, then for 39 more rows. Basically, for the quickest Bulgarian visa, I have to establish a trade representative office for a foreign company there, then apply for a visa as a trade representative for that company. Okay, yeah. I mean, yeah, if you're doing that stuff, then I guess there's a lot of paperwork. Just do count. No. Row equals get tile I for I in range. Row. Up late watching Hex plays lead code and fucking around with a local Cades cluster. Well, it's quite different from leak code. Well, I haven't done leak code in a long time. It's quite different from leak code. It's simpler and easier than leak code. Oh, is that short for Kubernetes? Okay. Yeah, so far ChatGPT has been destroying me in all of these problems except for three where it got confused. And one where it made a bug, and I knew what the bug was, but I couldn't tell him, so I was just kind of giving him hints. Alright, and then join that up. And then, how are you measuring it? How does ChatGPT beat you? I just copy and paste the problem description into ChatGPT and ask it to give me a Python program to solve that. Because it codes far faster than you ever could. Yeah, it does, yeah. That's why it wins. But I beat it in 3 problems at least, by actually giving correct code. Count plus equal. It's a matter of tests passing. Not so for admins of code, it's just a final answer. It'll be like an integer or something. They've given you an input. In this case, our input was this row, but sometimes it's a text file with 100 rows or something. And you've just got to get a final answer, which is usually just one number, and you put that into the site, and it'll tell you if you got it right or not. So you don't have to submit code like you do in some other coding sites, like Leak Code, for example. In this case, you just use whatever code you want on your own machine and then just give them the final answer. It's a more relaxed version of Leak Code, and I think it's actually more fun, especially during December when when it launches. Then for 25 days, like it's becoming more and more popular every year. A lot of people take part in it, they stream it and discuss how they solve the problems. It's good. It's now my favorite type of, I don't know, coding challenge website. I've kind of got bored of some of the competitive coding sites. Let's equal row dot count dot. There we go. And then print count. Is that it? All right, run it. 1961. Of course, ChatGPT is kind of spoiling the competition, but I mean, most people just do this for fun anyway, so it doesn't matter. But there is a leaderboard for the top 100, and that's kind of spoiled by ChatGPT because people are just solving it in seconds just by pasting it in. mean, last December was kind of the first year that happened, because that's, you know, when ChatGPT launched. But okay, that was correct. And then when you solve part 1, they then give you a twist or a modification. So now they're asking how many safe tiles that are there in 400,000 rows. I think we could still brute force it. 400,000, that's actually alright. It's not something I need to come up with a clever algorithm for. Yeah, okay. Just change it to 400,000. Sometimes it's a twist in a way that you actually need to fundamentally change the paradigm you're using for your algorithm. But in this case, I think it will just work. I think it's sufficient enough. So we want 3, 9, 9, 1, 2, 3. Well, I want this code to solve both parts. Just, I don't know, I might archive it, so I'll put it up on GitHub or something. So start part 2 down here. So this one will be 399,999. Alright. Run. So it'll take a while, but I think it's perfectly within the bounds of possibility here. So 400,000 multiplied by the length of that row. We're not storing all those rows, so we're saving on memory. We're just replacing the row with a new one. Okay. There we go. That should be correct. If 39 was correct, then... Oops. Huh? Too high. Okay. Okay, firstly, did I do the number correctly? How many safe tiles are there? 400,000. 400,000 rows. Oh! Damn it. I gotta reinitialize the row here. It was using the row from the previous case. Yeah. So far this year that I'm doing, 2016, has been, I would say, on the easy side. So last year I did it live in December, which was the 2022 competition. There were some difficult problems in there that would take me hours to solve. So far these ones have just been easy. But this was the second competition he ever did, so probably he was just building up from there in terms of difficulty. Eric Wustel is the guy behind this site. He came into my chat once when I was streaming Advent of Code. There we go. Alright, now we test on ChatGPT, so we say, can you write a Python program to solve the following problem? And then you just paste the problem. And we need to also give the input. Freaking ChatGPT wouldn't build me a website. Was it a complicated website? Let's just copy this and say... Alright, well, let's just take out the quotation marks. Alright. Yep, looks pretty much like my code. Alright, I don't like this bit here. I think what I did was just more compact. I said it was in, like, one of these 4 substrings, one of these 4 strings concatenated. But otherwise, it's pretty much the same. When you run this program, it will output... No, it doesn't. So he keeps doing this, and that's kind of... It's because someone has actually asked this question, this exact question in the past, and it's just pasting the answer it got for their code. But they had a different input to me, so it's not 1982. For my input, it's 1961. So I don't like that ChatGPT does that, because that's a lie. That code does not correspond to that answer. It's just guessing. He didn't actually run the Python code, so... It's like if you ask it what a legal letter would look like, it will say it can't write a letter for you. Then you say, I didn't ask you to write it for me, I asked you to give me an example of what I should write. Uh-huh. Okay. I mean, I haven't really heard... From what I've heard, everyone who's been asking it for stuff has always been getting this stuff. Like, it's been writing, you know, like sitcoms for people, it's been writing code for people. I haven't actually heard many people say that they've been refused anything. It might be that they've changed it in recent weeks, I don't know. Ask it to write you a business website. But I mean, maybe those people are using the paid version though, I don't know. There must be a difference then between a significant difference between the paid version and the free version. I'm saying, okay, yeah, I'll do that. Let's run this code first. But I mean, you'd have to give me something more specific. If I just say give me a business website, I expect he wouldn't do it. But if, like, do you have a more specific request? All right, I need to make a new file here. Like, I don't know, for maybe like for a shop, online shop or something. Three, 4, 7, 5? That's way off. Okay. Interesting. I didn't think he'd get this wrong. See if we could spot the bug. Trap, safe. Trap, safe. Wait, what's this? Trap, safe, trap. That's wrong. It's supposed to be... Trap, safe. Safe, trap. Trap, safe, safe. Safe, trap. Trap, safe, trap. So he's not read the logical conditions correctly. Interesting. Alright, I mean, I can't tell him what the bug is. I just have to tell him the answer is too high or something. Misunderstood the rules. That is indeed what he did wrong, so... To correctly solve the problem, we need to generate the rows iteratively, keeping track of the... Well, that... I'm not sure whether you actually... No, still wrong. I'll just quickly try this, but I'm pretty sure it's wrong. It's wrong, yeah. Now it's 2005. What? It's just fishing for past answers. All right. Still too high. There must be a bug. The bug lies in the way the new rows are generated. No, it doesn't. That's not where the bug lies. Should be done using indices from 0 to length previous row instead of 1 to length. Well, that's true. What was he doing before? Ah, interesting. Yeah, that is a bug. Okay. Well, he's found another bug, but that wasn't there. But he's still... Yeah, it's still wrong, though. Why do I sound disappointed? This is good. This means I win. Right. I gotta keep trying, though. See if he actually gets to it. Gets to the solution in a reasonable time. No, that's not where the problem lies. He doesn't get it, does he? So, if we're making this fair test, so when you actually submit and you get it wrong, you're not allowed to submit again for like a minute or something. So every time he gets it wrong, he's adding on a minute of kind of time. So, in theory, we've used up like 5 to 10 minutes so far. And I took a really long time to code that because I was chatting with Slinky as well. So probably if I wasn't chatting so much, I probably would have solved it in, say, 15 to 20 minutes. So he's running out of time. But we can try another couple of attempts. The count of save tiles should not be added to save count before generating the subsequent rows. Huh? It's independent. You can. It's safe to add count to save count. Yeah, that's not right. Yeah, come on. The bug is staring at you in the face, ChatGPT. There, it's right there. Center and right tiles are traps, but this left tile is not. Yeah, he just doesn't. He doesn't get this. Wait, which? He's accounting for. Yeah, these last two conditions. So he's not reading these two sentences correctly. Only its left tile is a trap. He interprets that as meaning the left and the right tile are traps. How did he get that? All right. Last attempt. Because he's got to do part 2 as well, so he's run out of time pretty much. Still wrong. Please find the bug. No, he's obsessed with this row calculation, but that's not the issue. Nope. I have to still try it, but it's wrong. Nope, it's wrong. Okay, I mean, I knew it was wrong. All right, he loses. Let's just tell him what he did wrong. Wrong. Yes, he gets... No, wait, does he? He's only going to correct that one, but not the one that comes next. I mean, he's lost already. I'm not counting this now. Oh, damn it! He's done. He's still got this one wrong. All right, he failed. I can't be bothered to get the correct answer out of him, but he would. But I had to tell him the bug, so. We win that one. All right, 19. On to 19. Out of interest, let's just have a look at some of these stats. So people found 18 fairly easy, and 19 and 20 and 21 all seem to be similar. These ones seem to be a bit harder. It seems like 11 was probably considered to be the most difficult. Let's have a look at what was 11. Ah, yes, this was the elevator puzzle, which was like, oh yeah, this was hard actually, yeah. Basic breadth first search takes too long. You had to find some clever optimizations. This was basically the fox and the goat, the wolf and the goat and the cabbage puzzle with the river, but scaled up to a very large input. Well, not a very large input, but large enough that you wouldn't really want to try and solve it by hand. All right, so let's move on to 19. An elephant named Joseph. Ooh, nice short problem. I like these ones. The elves contact you over a highly secure emergency channel. Back at the North Pole, the elves are busy misunderstanding white elephant parties. Is this referring to the King of Siam thingy? Oh yeah, there he is. I've never seen a white elephant gift exchange. Sounds interesting, but also kind of wasteful. Oh, each gift can only be stolen twice per game. Actually, we did do something like this in at my last job, but it wasn't meant to be impractical gifts. It was just like you could bring in practical ones as well. It was just kind of mixed bag. Some people brought impractical ones, some people brought practical ones, and that made it more interesting to fight over the presents. Alright. Each elf brings a present. They all sit in a circle, numbered, starting with position 1. And starting with the first elf, they take turns stealing all the presents from the elf to the left. An elf with no presents is removed from the circle and does not take turns. 5 elves. Elf 1 takes elf 2's present. What? So elf... An elf with no presence is removed from the circle and does not take turns. Removed from the... When are they removed from the circle? If I'm reading this literally, Elf 1 would take Elf 2's presence, so at this point Elf 2 has no presence. So if you were following this sentence here, Elf 2 would be removed from the circle and does not take turns. But it just says he's skipped. But he does come back into play later on, so I'm a bit confused here. So it looks like removed from the circle. They're not actually removed from the circle. They stay in the circle. They just have their turn skipped. Removed from the circle. Alright, fine. They're just skipped. 1 takes 2's present. 2 has no presence and is skipped. 3 takes 4's present. 4 is skipped. 5 takes 1's 2 presents. Doesn't... No, okay, fine. Neither 1 nor 2 have any presents, so both are skipped. Elf 3 takes 5's 3 presents. Oh, I see. They're sort of... Okay, fine. They're removed from the circle because they'll never get presents. If you don't have presents, you can't act. And you can't get presents unless you act. So they may as well just not be in the circle anymore. Okay, I get it. So these ones that are being skipped, they'll be skipped forever. But it keeps mentioning them. But you might as well just pretend they no longer exist. Alright. Elf 5 takes 1's presents. Fine. Elf 3 takes 5's 3 presents. So with 5 elves, the elf that sits starting in position 3 gets all the presents. So you don't care how many presents there are. All you care about is elimination. You eliminate the person to your left, and then the ring gets smaller. So 1 eliminates 2, and then it's just 1, 5, 4, and 3. 3 eliminates 4, then it's 1, 3, and 5. 5 eliminates 1, so then it's just 3 and 5. 3 eliminates 5, and then it's just 3. There must be a clever way to shortcut this. Okay, fine. So... That's our input. Oh, I see. Yeah. Ugh. So what actually happens? In the first pass, every even number gets eliminated. But then you get to 5. If it were an even number, so if you have an even number of elves, then every even numbered would disappear. If you have an odd number, then every even numbered would disappear, as well as elf 1. That seems to be what happens in one pass. How does that help us though? That's just one pass. After that it becomes... Interesting. Hello, Maro. This one seems more of a puzzle. I mean, I can't just initialize 3 million elves. That's gonna take too long. What would it? I don't know. It's kind of like the size is halving every time, so it probably wouldn't actually take that long. If we try and be a bit smart about it, we can say... What's the pattern here? So, okay, we eliminate 2 and 4, and then we eliminate 1. And then 3 eliminates 5. Alright, I mean, I don't need to be too clever with this. Let's just... We don't need to create that many elves. But we could have a queue. So initially they're all in the queue. In order. And then you take someone out of the queue. I mean, this is literally just walk around the circle and eliminate every second person. So, hello Slinky. What did I miss? Well, ChatGPT couldn't solve that problem. I mean, I knew what the bug was. He just wasn't getting it. The bug was that the original description said one of the conditions is only its left tile is a trap. Out of 3 tiles, that would mean it's trap, safe, safe. But ChatGPT interpreted that as basically like this. Trap, safe, trap. And trap, safe. Trap, but see, look, those two are the same. Yeah. So he just didn't understand these 2 sentences here. Only. He didn't understand the only bit of this sentence. And despite repeated attempts to encourage him to fix the bug, he couldn't find it. It's a language model. He doesn't really have anything for logical math. Well, I mean, if logic or maths is used in language, then he's training on that, so he picks up everything. So he's definitely capable. I mean, he got the first 2 logical conditions correct. He just got the next 2 wrong. I told him what the bug was, and then he fixed it. So this is what he said. So it's like, you're right. The logical conditions. So he definitely understands logic. He just made it. He just got it wrong the first time, and he didn't realize. So he corrected it when I told him what the bug was. Well, actually, he corrected that line, but he didn't correct the next line. But yeah, I mean, that's a fail because I had to tell him what the bug was. I think this might be a linked list problem. It's not often that you get linked list problems. But it is a linked list problem. It's a circular linked list problem. But you don't need to make it a circular one. You could just, well, we could do it as a circular linked list. Alright, well, I can't remember the last time I coded a linked list. This will be fun. It's like the first thing you learn in CS 101. Wait, read the problem for those of us who are actually looking at a terminal at the moment. Okay, so you've got a bunch of elves numbered 1 to n sitting in a circle. You start with elf 1. He takes all the presents from the guy on his left, which is elf 2. When an elf loses all their presents, basically you may as well just assume they don't exist anymore. So the circle closes, so it's now 1, 3, 4, 5. Now, and then you go to the next elf. He steals all the presents from the guy on the left. So stealing the presents is just another way of saying eliminates the person to the left. So 1 eliminates 2, 3 eliminates 4, 5 eliminates 6, and so on. So basically, it seems like you're eliminating every even numbered. But then after that, it's then you, what rate are they stealing presents? Well, you're doing it turn by turn. So 1 does his turn. So 1 eliminates 2. And then you move to 2, but 2 doesn't exist anymore. He sits out. Then you go to 3. 3 does their turn. So you just go turn by turn. They take it in turns. And you keep doing it until there's only 1 elf left, and you want to know which elf is left. But then 1 has 2 presents. To be honest, it doesn't matter how many presents they've got. All that matters is whether they have presents or not, because ultimately you just want to see who's left with all the presents. And they'll have n presents, so the number of presents you don't need to keep track of. Then 1 has 2 presents. Yes, that's correct. 1 has all the presents. 1 has some number of presents. It doesn't matter. Yeah, they steal all of them in one turn. Yeah. So in the example here, there's 5 elves. So if 1 eliminates 2, 3 eliminates 4, 5 eliminates 1, 3 eliminates 5. So 3 is left. Now, I'm just wondering if there's some clever mathematical pattern here to make it very fast to work out who's left. I mean, in the first phase, every even number is eliminated. That's apparent. But then, if you've got an odd number, then 5 eliminates 1. And that's where things kind of... Binary tree... I don't see how a binary tree applies. It might be that there's some clever mathematical formula for working out who's left. But if we want to code it without worrying about it too much, I reckon it's a circular linked list problem. So you just create a linked list where 1 is pointing to 2, 2 is pointing to 3, and so on. You go through the list, and each time you get to someone, you basically delete the node that's next. And that can be done without... So in Python, if you delete things from a list, that's actually a really expensive operation. If I try to do that, I'll have to do 1,000,000 times 1,000,000, so that's hopeless. I can't use Python lists, so I have to create my own linked list. If the number of elves is even, drop half, otherwise drop the first on the list. Yes, that does happen. Otherwise drop the first in the list. Well, you drop the first in the list as well as all the even. Are you trying to describe some sort of recursive algorithm? Yeah. I don't see how you could do that without ending up using quadratic time, because you'd have to rebuild a new input which is of linear size. Well, wait, it's not quadratic time, because if you're halving the size each time, it's basically 1 plus a half plus a quarter plus an eighth, which adds up to 2, so it's actually linear. So I can actually do this the brute force way, the really slow way, without... I think it'll be more fun to do it with the linked list, though. I think that's actually efficient. While length elves is greater than 1. Yeah. Yeah, no, that seems completely correct. I was hesitant to do it at first because I thought it would be quadratic, but yeah, I didn't realize if you're halving the size each time, then actually it adds up to being just basically twice the original size in terms of maybe log n. No, it will be n, because you have log n number of iterations of the while loop, but in each iteration of the while loop, you're spending linear time in rebuilding elves. Well, at least you are in the first iteration. The second iteration, you're using half of n, then a quarter and an eighth, and so it actually... that's why I said it adds up to linear overall rather than quadratic. But it's not log n, though. It'll just be n. But it works. I think I'll just, even though it's actually pretty easy to code it the complete brute force way, just creating a list, as you've said there, while length elves greater than 1. I'll try doing it the linked list way, just to be creative. It might help with part 2, because I bet part 2 will give us a bigger input size anyway, in which case we'll be back to square one if we try to rebuild Python lists over and over again. Alright, so alright, I've spent ages chatting about this. Let's create... Well, part 2 will be they only steal 1 gift at a time or something. Maybe. Alright. 19. Okay, so input, let's say n equals that. All right. This is taking me back to my university days. How do we make a linked list? Well, you just say class linked list. Put a capital L. Named tuple. Okay, so class linked list. Fine. So we have there's also data classes now. Oh yeah, I've been using them for the coding game streams that I've been doing. It's good stuff. It really simplifies initialization and stuff. I just haven't. I keep forgetting about those. I should. Yeah, I've just got to use them more often because I wouldn't know how to do them right now if I had to use them. But yeah, it's not that hard. Self. So we've got a next and a num. So it doesn't have a next, and so hang on. No, we don't need a. Don't need that as an input. It just has a num. Self.num equals none. Okay, and self.next is none. That is the entirety of the class. Okay, so. Let's say head equals linked list. So we create a node for the first elf, and now for I in range up to. So from 2 up to and including n, say tail equals head. All right, how do we do this again? So we say we want to perform a simultaneous update. So we want to say uh, tail dot next equals. So we now add a new node onto the end of our linked list. And then update the tail to be push the tail forward. Okay, yeah. So by the end of this, we'll have a linear linked list. We just want to make it circular now. So we want to say tail.next equals head. And therein the loop is closed. We still have a head though, so now we do while while head.next is not well while while head.next.num is not equal to head.num. So I'm saying while we have more than one item in this circular linked list, so head is not pointing to itself, that's the only way we can check if it's pointing to itself, because you can't test equality for, well, you sort of can. It would work because it would just use the memory address of the, yeah, okay, we'll do it that way. So say head.next, while head.next is not equal to head, while it's not pointing to itself, we take head and we eliminate the guy to the right of it. So that means we just say head.next equals head.next.next. That's how you delete the next node. You just say my next value is the nodes that's after next. Okay. So if 2 will now be forgotten. 1 is pointing to 3. And then the last thing we just have to make sure is, hello Onion. But not in maths. Well, for now. Yeah, you're right. Yet. I'm interested to see what he'll do for this problem. But he'll probably do the brute force way and it will probably work fine, to be honest. I'm doing it the somewhat smarter way than brute force, but it's probably not that much faster. Slower to code. Alright, and then we have to update head is now head.next. Alright. And then very final thing we do is print head.num. Alright, will that run? Alright, is that the answer? So that's efficient because every step takes constant time. We never have to rebuild a full list. Ah! It's wrong. Okay. You don't have to rebuild a full list. No. But you do if you use a Python list. That's why I had to make my own list. Well, what I did was wrong, so let's test it on the example at least. So 5. Okay, we can debug this then. It's supposed to be 3. Head equals linked list 1. Okay, so we start by creating 1. Tail.next equals. Just experimenting with GPT on FizzBuzz problem. If you ask it to use match case syntax from 310. Oh, 310, what's that? The version of ChatGPT? It fails. But if you ask to write initial code in Rust, which has pattern matching, and ask to convert to Python, it works just fine. I see. Oh, Python version, okay, fine. Huh. But they do say on the site that if you use resources that are new within the last, if you refer to resources that are new on the internet in the last year or so, ChatGPT will kind of often not know about those things because they've mainly trained it on stuff from long ago. Well, not that long ago, but from, I think they said the cutoff was like 2021 or something. I don't know. But I think it does actually know quite a lot from recent months. It's just they can't guarantee it always. It's GPT-4 from Bing. And it knows 310 syntax. Okay. Wait, so what am I using? What's I don't know what version is what. The free version is GPT-3? Or free version is 3.5 turbo, I see. Which is fast but not precise. So you're using 4, and I assume that's one of the paid options, or the plus option. Bing.com chat. Oh, I see. Microsoft are using that version for their chat. I see. Okay. Might need to install extra extension. Okay, that's interesting to know. I guess for the purposes of this experiment, I'll have to stick with the same version I've been using so far, but I could look into that in the future. Alright, so what went wrong here? So we have a head, which is 1. So at this point it looks like 1 pointing to nothing. Alright, tail equals head. Okay. So like at this point we have that and that is both the head and the tail. Let's do that. Okay, so you also do coding game. Yeah, coding game was the first thing I started doing actual streams for, and I think it's still one of the best fits for streaming. It's just like more relaxed, because it goes over the course of 2 weeks, rather than some of these competitive coding sites where it's like you've only got like a few hours to do your problems. I like they promote streams. Yeah, exactly. Some coding challenge websites don't like you to stream because it's killing the competition, and that's fair because they are kind of more into the competitive side of it. But coding game is very pro like open community and discussing problems and sharing and streaming and stuff. So that's good. So for I in range, damn it, or I see the problem here. I started from 1. I should be starting from 2. Could that be the bug? All right, that might be it. Yeah, that's it, I think. Because 1 I handled manually, and then 2 onwards is automatic. So just change that. There we go. There was 1 fewer. I mean, of course, yeah, you... Yeah, okay. Yeah, it's right. I mean, one of the things you should try when you got the wrong answer, if you're going for time, you should just try 1, go down by 1, because if it's a one-off error, which it often is, then that was probably the issue. Okay, so part 2. Oh, okay. This is not just a number change. This looks like something different. Realizing the folly of their present exchange rules, the elves agree to instead steal presents from the elf directly across the circle. Alright. Well, circular linked list doesn't help us here, unless... It might. If we keep a pointer to... Let's just read this before I worry about that. So, if 2 elves are across the circle, the one on the left, from the perspective of the stealer, is stolen from. Yeah, okay. The other rules remain unchanged. Elves with no presence are removed from the circle entirely, and the other elves move in slightly to keep the circle evenly spaced. So 1 steals from 3, okay. We might need to make this a doubly linked list. Alright, so 2 steals from 5. Yeah, okay, I get the rules. Alright, Onion, yeah, I will continue streaming. I mean, I'm certainly going to keep at it with 2016, and then move on to all the rest of these years. So, 2017, 18, 19, and 21. I don't think I'll even manage to finish all of those before Christmas, in time for the actual live 2023. But yeah, I'll throw in some coding game stuff as well. And there is a coding game competition coming up, something like next week or something. So that'll be fun. Proper bot coding competition. The last one was not bot coding, it was a bunch of programming puzzles. I didn't like it. It wasn't well implemented. Alright, yeah, I'll see you next time, Onion. Oh, and thanks for the follow as well. All right. So I think we just need to change. So I think now we need a pointer to see. Okay, so 3. So 3 gets eliminated. And then the circle closes slightly. And then 5 gets eliminated. Could it be something as simple as 3 gets eliminated, you move 2. You move 2 spaces, you now eliminate 5. You move 1 space, you now eliminate 1. You move 2 spaces, and so on. Is it just 2, 1, 2, 1, 2, 1? Because it's alternating between even and odd, so is that the pattern? So if we had... I'm actually going to have to get some pen and paper for this. But I feel like that's just the pattern, is 2, 1, 2, 1. I think the number you skip grows exponentially with the number of elves in the circle. Oh no, you're... Okay. Well, I was actually really talking about this in the frame of the linked list. So, when you're talking about the actual raw number, then yeah, you're probably right. But if I am remaining oblivious to the raw number, just worrying about the linked list, then instead of trying to compute who's sitting opposite some node in a linked list, all I need to do is start with 3, who's opposite 1, and from that point on, we just move 2 spaces, cut that out of the linked list, move 1, cut that out of the linked list, then move 2, then 1, then 2, then 1. Is that correct? Without worrying about what the actual value is. This example's too small to check this. And then I'm left with just 1. If you had a circle that was 32 wide, it would be 16 sitting across 12. One, yeah. Mm-hmm. But you start at 16. You don't start at 1. I don't care. I don't even care about who's doing the stealing because they're irrelevant. All I care about is keeping track of who's being stolen from. So you're still having to traverse the list farther than 1, 2, 1, 2. So if we start with 16, don't worry about 1. What happens? I can't visualize this in my head. I might need to scribble something. So as far as I'm concerned, nobody's even stealing presents. It's just people losing their presents. Because the fact that someone takes presents doesn't matter. They'll just have presents. I need to get a pen. All right, so let's go with like, I don't know, 10, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so 1 is opposite 6. Okay, so we start with 6. 6 gets eliminated. If we're keeping a pointer pointing at who is the next to be eliminated, we move that pointer to seven. Yeah, so we move forward 1. 7 now gets eliminated. So now we move the pointer to 9 because 9 is opposite 3. So far it's holding up. So we moved 1 and then we moved 2. Now 9 is eliminated. And now who's opposite 4? I need to draw a new circle now because this is confusing. 2, 3, 4, 5, 8, 10. Alright, so our pointer was at 9. Okay, so who is opposite 4? 10. 10 gets eliminated, and 10 was indeed 1 forward. Okay, I just need to check one more and then I'll be convinced. So 10 is out. Now who's opposite 5? 2. Yeah, it works, I think. Yeah, okay. That's the rule. Let's just code that then. So you actually don't need to worry about who's doing the stealing. Just keep a pointer moving 1, 2, 1, 2 for who's vanishing. So if your intuition is right, then bravo. Yeah, I am now quite confident. If the pattern held for that, I don't see how it could ever deviate. Okay, so yeah, let's just check this then. So so n remains the same. All right, let's just create a new. All right, so create a new circle linked list as before. Head equals linked list 1, tail equals head. Yeah, okay. This doesn't need to change. Okay, so we've got a circular linked list now. Now we want to find the where to put the head. Just put head at 16 or whatever it is, the n/2. Actually, 1 before, because we want the pointer to be 1 before. It makes it easier to delete the next node because you're just modifying the next values. So we want so let's say x equals n/2 minus 1. We're looking for the node whose num value is that, right? Not n/2. Okay, so while head.num is not equal to x, head equals head.next. So now head is pointing at wait, is that the right value? No, I don't think is it n/2 minus 1? I lost the page I was scribbling on. No, it's not. It's not n over... What is it? It's... It's just n over 2? Wait, it's... Hang on, so if it's even, if n is even, then it'll be n over 2. 6 was opposite 1. If it's odd... If it's odd, then it would be n over 2. Yeah, it's n over 2. We don't subtract the 1. Okay. While head.norm is not equal to x. Okay, fine. Now we do this loop. While step equals 1, and this is going to alternate between 1 and 2. So we start at 1. All right, so while head.next is not equal to head. Okay, so while, yeah, okay. For do that however many times we're stepping. So no, this is not quite right. We delete the next node once, and then we step forward I mean, okay, so you don't actually... If step is 1, you don't step at all. Your next value is already the one you need to delete. So it's actually step minus 1. But if your step value is 2, then you would actually have to skip forward by 1. Okay. And then step equals 2 if step is 1 else 1. I feel that something could be wrong here. I don't know. All right, just print the value. Okay, so just test it. If it's wrong, I could try on the example. That usually helps a lot. Yes! But I mean, this is one of those problems where if I just went for the brute force approach of initializing an entire list of millions of nodes, it would have taken longer to run, but it probably, coupled with the amount of time I spent coding and thinking about it, probably would have been faster, to be honest. But I think definitely this code is more elegant. Well, it's not very readable. This linked list stuff is kind of actually quite ugly, but it is elegant from a memory management point of view because we're not messing around with all that list rebuilding. All right, I am curious as to what ChatGPT will do for this, but he might just go for the brute force approach. That's actually not that hard. I feel like the result is actually guessable with a constant formula. Yeah. Yeah, that's what I felt at first. I'm sure... yeah, I mean, back when I was studying maths, there were lots of problems like these which had elegant solutions, so I wouldn't be surprised if there was a closed formula for this. These are the kinds of questions they always used to ask for entrance level interviews for universities in the UK, at least. Especially my university. But harder questions than this. Or at least more complex ones. Not, well, I don't know the answer to this, so I don't know how hard this one is, but... Yeah, have a think up for a minute or two. I mean, it's something to do with modular arithmetic, but it's a bit weird. I don't know. Alright. Can you write a Python program to solve the following problem? Square root is involved somewhere. Interesting thought. I don't see why. Where would square root come into it? I think maybe one of the problems are that we are taking the elves out of the circle. Maybe we shouldn't be taking the elves out of the circle, but instead be considering that we're skipping over larger numbers each. I don't know. A pattern that would follow whether the number of elves was odd or even, and then the half of it was odd or even. It's an interesting one. Let's see if ChatGPT knows this then. Maybe he knows the closed formula for this. No, we got only part one. Using a list to represent the circle of elves. What kind of list? Okay, Python list. So he's gone for the I guess, the most obvious approach. It does look more readable, certainly. Okay, so he's... Wait, what? Yeah, let's have a look at this. If num elves... So if the number of elves is even... Wait, what? Iterating and popping from the list, so Python's actually offloading, recreating the list to its C code. Yeah, it's rebuilding the list. So let's oh wait, I was wrong initially. It's not linear time. It is actually quadratic, because if you're popping one elf at a time, yeah, you're rebuilding a list of linear size every time, so it'll be n, then n minus 1, then n minus 2. You're not actually halving it each time, because I don't... Well, I don't know exactly what they're doing, but if we're talking about the most obvious approach, which we were talking about to begin with, I said it would be n, then n over 2, then n over 4, but then I realized you're not actually taking half of them out at the same time. You could, though. You could program it that way, so you create a temp list of what you need to remove, and then you remove them all in one big batch. Then you are actually only rebuilding the list once per phase, so then it would actually be n, then n over 2, then n over 4. You just need to just add more code for that, but yeah. But yeah, taking out one elf at a time, that is definitely too slow. So I don't know what they're doing, so let's... Elves.pop steal from. Well, if they're doing pop, that is going to take too long, surely. Because they are doing it one at a time. We've got 3 million. So it's quadratic. 3 million times 3 million. Let's try running it, but pop index out of range. He's always doing... Oh, I think I see the problem. He's zero indexing, but he's also using 1 to num elves. You can't do both of those. You got to change it to be 0 to n minus 1 if you want to do this. Otherwise, he should be adding 1 each time, shouldn't he? Like, if I did that, would that... He's not. Look at the for loop. For I in range num elves. Yeah, the I value is fine, but it's the... Oh, yeah. Actually, yeah, you're right. That's okay. The I is fine. Yeah, okay. Yeah. So then that's... Wait, so, okay, so how are we getting a index out of range then? If steal from is always going to be modulo num elves. Because num elves changes each iteration of this loop, but he's not actually changing it. That's the problem, isn't it? So now num elves should be smaller in the next iteration of this for loop. But num_elves is still what it was initially. So this should be here. And maybe here as well, but let's try running that now. Is that not the problem? That does seem like a problem though, because the next iteration of the loop, it's no longer safe. It could be resetting num_elves should be at the end of the for loop, not the beginning. Would it make a difference? Yeah. Because it's always happening in between, either way. The range num_elves is already evaluated. It doesn't re-evaluate each iteration. Yeah, that's definitely a problem. It evaluates once, but we need it to... Wait. Hang on, what do we... Yeah. I mean, yeah, that's how I would normally code it. True with a break statement. You don't want to... Yeah. So you'd want, well, I mean, it's not my job to fix it. Let's tell ChatGPT he's wrong and see if he fixes it. Yeah, but that does seem to be the problem, and alright, so I'll give him the... What's to 5 in the morning, so I'll be drifting off soon. Okay. Well, the sun's just about to go down. Could actually move outside. I'll only have about an hour before it gets pitch black, though, usually. Alright, let's copy the full trace back. Into... Alright, so... I get the following error. Please fix it. Yeah, okay, he gets it. It's not updating the num_elves variable inside the while loop. Here's the corrected code. So it's a while len_elves is greater than 1. Yeah, that's right. Different problem now? Was that the whole issue, or is there still an issue here? Num_elves equals length_elves. That's correct. Uh-huh. Pop steal from... Oh, but he's still not updating num_elves in the for loop, is he? That's the other issue here. Logic for stealing presents and updating the indices correctly. Okay, he's not relying on numb elves, so that's looks better. Wait, what? Where does this come from? Current elf plus that divided by 2. I don't want to think about it too much. Let's just test it. Five elves, last elf standing is 2. Oh no. Has he solved part 2 instead of part 1? I never even told him part 2. I did give him the correct one, didn't I? Yeah, I gave him only part 1. That means he's using stuff he's seen before. That really messes things up, doesn't it? Not much we can do but just tell him it's wrong. Yeah, so this is what you need for stream's over. What do you mean? Is the stream down? Oh, you're telling me to end the stream. Okay. You get me worried because sometimes the stream does cut out. Alright, yeah, I mean, this kind of spoils things because then it's like, if I was trying to cheat in this competition, this wouldn't make sense because he wouldn't know. Cheat GPT. I mean, I don't know. Okay, let's tell him. Wrong answer is giving 2 instead of... No, we don't know what the correct answer... Oh, no, we do know. It's an example that's giving the wrong answer, and so 3. Oh yeah, and the code's still running. That means it's too slow for the big case, isn't it? The code is still running and it's not finishing. It's quadratic. It's too slow. For the example, also for the puzzle input, it is taking too long to finish. Yeah, so this is one problem you actually did have to be smart about. Either by doing what I did with a linked list, or by doing some sort of batch process so you don't pop one thing at a time. But he's gone for the slow approach and it's not going to work because a million times a million is beyond what any computer can do. Well, not efficient for large numbers of elves. Let's use a different algorithm. We can use a recursive approach called Josephus problem? Huh? Well, the name of the problem is indeed an elephant named Joseph. So is this... Wait, what? What is this? I've never heard of this. Ah, so this is actually pretty established problem. And that is why it was called an elephant named Joseph. All right, that's cool. So is there like a closed formula then? Solution. It's a recurrence relation. Increasing odd sequence that restarts with fn equals 1 whenever the index is a power of 2. So it's not completely constant time, but it seems like it is there. But close enough. It's logarithmic, basically. You would have to find the m value. But yeah. Power of... no. Not square root. It's logarithm. You would need to use the logarithm to get the exponent. If you want to know if it's a power of 2. Why would square root... wait, what? Why would square root tell you if it's a power of 2? Surely you just have to divide by 2 repeatedly until you get to an odd number. I don't think it's related to square root. But you don't really care if it's a power of 2. What you really care about is what is the largest power of 2. Well, what is the smallest power of 2 above your number, essentially. Or no, below your number. You want to know this L value. So you want to know what is the largest m such that I am 2 to the m plus L. So you want to know m and L. So you would need some sort of... yeah, you would need to take the log to the base 2 of your number, and that'll tell you what m is. And then you get L for free. And then once you have that, then it's 2L plus 1. Okay. Pretty much a closed formula. It's not technically constant time, it's just logarithmic. But and yeah, you prove by induction. Okay. Cool. I'm surprised I've not come across this before. So this is a linear time algorithm. Which doesn't involve building up lists, it's purely just the numbers, which makes sense. I mean, once you know the recurrence relation, that's pretty efficient. I'm sure I've seen variants of this, but they were quite different to this, so... yeah. Josephus problem. Josephus permutation. Eeny, meeny, miny, mo. So back on the school playground, if you knew the recurrence relation, you would know exactly where to stand in the circle of school kids in order to in linear time. All right, Slinky. I'll see you next time. Usually it'll be earlier in the day as well, so. All right, see you next time.